Imagine for a moment that your solar system is a quiet, well-lit room. You've lived here your whole life, comfortable in its familiar glow, convinced you know every corner, every shadow, every dust mote dancing in the sunlight. You believe you understand the physics of this space. But then one day, a shadow falls across the floor from an unseen source, moving in a way that seems impossible, bending the very light you thought you understood. It's a whisper from beyond the walls of your cosmic home, and it demands your attention. This is the story of 3I Atlas, a messenger from another star system, a celestial enigma behaving in ways that defy our current understanding of cometary physics, immediately setting it apart from all previous visitors. It's the ghost on the film, a faint smudge on astronomical plates that quickly revealed itself to be a cosmic anomaly. Discovered on July 1st, 2025, by the Asteroid Terrestrial Impact Last Alert System, or ATLAS survey, a network of robotic sentinels. But as astronomers began to trace its path, a thrilling, almost unbelievable truth emerged. It wasn't from here, not our solar system, not our sun. It was an interloper, a genuine interstellar traveler, the third confirmed object of its kind. The ATLAS system, a NASA-funded planetary defense initiative operated by the University of Hawaii, suddenly found itself not just protecting Earth, but also catching glimpses of the truly unknown. Its initial designation gave way to the more evocative 3I, marking it as the third interstellar object. You see, its trajectory was unmistakably hyperbolic, meaning it was moving too fast to ever be captured by the sun's gravity. Its speed, an astonishing 210,000 kilometers per hour, was a clear declaration of its unbound nature. It was simply passing through, a cosmic bullet on an almost straight path, destined to leave our solar system forever. Now, you might be thinking, haven't we heard this before? Didn't Oumuamua do something similar? And you'd be right to make that connection. The ghost of Oumuamua, the first confirmed interstellar visitor in 2017, looms large over the current debate. Oumuamua was a mysterious asteroid-like object, devoid of a visible coma, yet it also exhibited non-gravitational acceleration, a subtle push not accounted for by gravity alone. This led some to controversially suggest it might be an extraterrestrial artifact. Then came 2I Borisov in 2019, which behaved much more like a typical comet from our own solar system, with a clear tail of gas and dust. But here's the aha moment, the critical distinction. Oumuamua was a passive rock. This new visitor, 3I Atlas, is different. It's active. It's alive with energy. It's screaming into the vacuum of space, spewing forth material. The core of the mystery lies in its non-gravitational acceleration. This isn't a small deviation. It's a significant departure from a purely gravity-defined path, indicating that it's losing a massive amount of material through outgassing, essentially pushing itself forward like a rocket. But here's the paradox. The calculated mass loss required to explain its acceleration seems to conflict with observations. An object shedding enough material to generate such a powerful thrust should consistently display a massive, bright cometary tail. Yet, 3I Atlas has often been surprisingly subdued. This brings us to its truly unearthly composition. Thanks to the unparalleled observational capabilities of the James Webb Space Telescope, scientists were able to get an unprecedented chemical breakdown of the gases emanating from its coma. What they found was truly shocking. An unusual composition dominated by carbon dioxide with surprisingly little water vapor. Imagine that, a comet, traditionally thought of as a dirty snowball, made mostly of water ice, is instead a dirty, dry ice ball. This suggests that 3I Atlas formed in a much colder environment than comets in our own solar system, perhaps in the frigid outer reaches of a distant ancient stellar nursery. This object is a time capsule, potentially up to 7 billion years old, originating from the Milky Way's thick disk, making it older than our own solar system. Then came perihelion, its closest approach to the Sun. This was the moment of truth, a period of maximum heating and activity. And 3I Atlas did not disappoint. After perihelion, it underwent a dramatic five-fold brightening, coupled with a color change to a distinct green hue. This sudden, explosive activity led to one of the most compelling theories, the catastrophic fragmentation hypothesis. Inspired by the disintegration of Comet 19Y4 Atlas, a comet whose death photos from Hubble showed it shattering into over 30 house-sized pieces, scientists theorized that 3I Atlas may have exploded near the Sun. But the oddities didn't stop there. Post-perihelion observations revealed a complex and bizarre structure. Instead of a single uniform tail, astronomers observed a multi-jet fireworks display with at least 7 distinct jets of gas and dust. And then there was the anti-tail, a visually striking and scientifically bizarre feature that appeared to point towards the Sun, defying the usual direction of cometary tails. These features were not just unusual, they were unprecedented. So, how do we explain such profound anomalies? This is where the debate intensifies, where science pushes against the boundaries of conventional understanding. Enter Avi Loeb, the prominent Harvard University astrophysicist. He argues that when natural phenomena cannot fully explain the observed behavior, we should not immediately rule out an artificial origin. Loeb suggests that just as with Oumuamua, the inexplicable energy calculations force us to consider all possibilities, including the radical idea that it could be an extraterrestrial technological artifact. This isn't just sensationalism. It's a rigorous application of the scientific method. This isn't just another Oumuamua. That was a passive rock. This new visitor is active. It's alive with energy, which makes its strangeness an even deeper puzzle. The clock is ticking. 3I Atlas is on a trajectory that will take it out of our solar system forever. Its closest approach to Earth is predicted for December 19, 2025, but after that, it's gone, back into the interstellar void from whence it came. This creates a natural tension, a palpable sense of urgency as scientists worldwide are in a desperate race against time. Teams at the Hubble, James Webb, the Very Large Telescope, and the Meerkat Radio Telescope are scrambling to gather as much precious data as possible. Every photon, every spectral line, every flicker of its bizarre activity is a clue, a piece of a cosmic jigsaw puzzle that might reveal not just the nature of this object, but perhaps the nature of intelligence beyond our world. This fleeting visitor, this ghost on the film, forces us to confront profound philosophical questions. Its existence is tangible proof that material from other stars regularly passes through our home system, blurring the lines between our solar system and the vast galactic neighborhood. What secrets does it hold about star systems far older and stranger than our own? And if, just if, its anomalies truly cannot be explained by natural phenomena, what does that mean for the ultimate question? Are we alone? We stand on the precipice of understanding something truly extraordinary, something that has journeyed across unimaginable distances to whisper secrets from a time and place beyond our wildest dreams. The answers to those profound questions about our place, about other worlds, and yes, about whether we are truly alone often begin with an observation, a flicker of light caught by humanity's tireless sentinels. Imagine, if you will, a vast interconnected network of watchful eyes spread across our planet, tirelessly scanning the inky blackness above. These aren't the eyes of ancient prophets or mythical guardians, but the precise robotic gazes of the Asteroid Terrestrial Impact Last Alert System, or ATLAS for short. Funded by NASA, operated by the University of Hawaii, ATLAS was built with a critical mission: to be our planet's early warning system. Think of them as humanity's security cameras, strategically placed to spot cosmic burglars, asteroids that might pose a threat, silently approaching our home. Their primary directive is planetary defense, to give us precious time if a dangerous object is on a collision course. But sometimes these watchful eyes catch something far stranger, something utterly unexpected that wasn't a burglar at all, but a messenger, something that wasn't a threat, but a profound puzzle. And to truly grasp the bizarre nature of what ATLAS ultimately found, we must first understand what normal looks like in the chaotic ballet of our solar system. Let's rewind our cosmic tape to a different yet related story. In late 2019, ATLAS performed precisely as designed, detecting a new comet designated Sahu 2019 Y4 ATLAS. Initially, it was a source of great excitement. Astronomers predicted it would put on a spectacular show, potentially becoming visible to the naked eye as it approached the Sun in 2020. This was a normal comet, a dusty snowball from the frigid outer reaches of our own solar system, flung inward by gravitational nudges. But the universe, even in its normalcy, can be dramatically unpredictable. As the 2019 Y4 ATLAS drew closer to our star, the increasing solar radiation began to do what it does to all comets. It heated its icy nucleus, causing gases to sublimate and burst forth, forming a magnificent coma and tail. Yet, for C 2019 Y4, this dance turned into a disintegration. In April 2020, to the astonishment of observers, the comet began to fall apart. The majestic tail dimmed, and what had promised to be a grand celestial display instead became a cosmic tragedy. The Hubble Space Telescope, with its unparalleled vision, captured stunning, heartbreaking death photos of C 2019 Y4 ATLAS. These images revealed not a single nucleus, but a chaotic swarm of at least 30 distinct fragments, each the size of a house, drifting away from each other, doomed to vaporize into cosmic dust. This was a normal comet, behaving in a dramatic, yet entirely understandable way. It broke apart under the sun's relentless gaze, a predictable end for a predictable object. This is our baseline. Now, with that baseline firmly in mind, the predictable, albeit spectacular demise of a solar system comet, let's fast forward to July 1st, 2025. Once again, the vigilant ATLAS survey, humanity's robotic sentinels, caught a faint, fleeting glimmer against the backdrop of distant stars. Another discovery, another potential comet. It was initially catalogued as D2025N1 ATLAS, following the familiar nomenclature. But almost immediately, something felt off. The preliminary orbital calculations, crude at first, began to hint at an anomaly. As more observations poured in from telescopes around the world, a startling truth began to emerge. This was no ordinary comet, no sibling fragment from the Oort cloud. This was no predictable icy wanderer on a familiar elliptical path around our sun. This was something entirely different. The data screamed it. This object wasn't just passing through. It was a cosmic runaway. a confirmed visitor from beyond our stellar neighborhood. Its trajectory was so profoundly unusual that it quickly earned a new designation, one that would cement its status as a true enigma. Defies. And here, my friends, is where our cosmic detective story truly begins, where the first definitive clue shattered our expectations and truly marked 3I Atlas as an alien. It wasn't its composition yet, nor its bizarre behavior near the sun. Those incredible revelations would come later. No, the very first undeniable proof that this object was not from around here lay in its speed and its path. We're talking about an extreme velocity of approximately 210,000 kilometers per hour, or about 130,000 miles per hour. That's not just fast, that's unbound fast. This isn't a speed that allows for a graceful, elliptical orbit around our sun. Imagine a child on a playground swing. They swing back and forth, always returning. That's an elliptical orbit, gravitationally bound. Now imagine that child pushing off with such immense force that they launch themselves completely out of the playground, never to return. That's 3I Atlas. Its orbital eccentricity, a measure of how much an orbit deviates from a perfect circle, was calculated to be an astonishing 6.137. An eccentricity above 1.0 means an object is on a hyperbolic trajectory. An eccentricity of 6.137 means its path through our solar system was practically a straight line. It barely even registered our sun's gravity as a gentle tug before it was flung outward again. This wasn't a comet that had been gravitationally scattered from the outer reaches of our own solar system, a lost child finally returning home. No, this was an object that had always been a stranger, a cosmic nomad whose journey began light years away. Its sheer velocity and its almost perfectly straight path were the unequivocal proof. It was moving too fast. It was a celestial runaway, a definitive clue that it wasn't from around here. It was a visitor from another star system, a tangible piece of another world, carrying with it the untold stories of a different corner of our galaxy. And so, this cosmic nomad arrived, a tangible piece of another world, carrying with it untold stories from a different corner of our galaxy. But what stories exactly? What secrets did 3I Atlas truly hold? Because the truth is, the more we looked, the less sense it made. Every new byte of data, every pristine image from our most powerful observatories didn't just add to the story. It twisted it into an even more profound, more baffling enigma. We thought we were tracking a comet, albeit an interstellar one. What we found was something far more alien, something that seemed to defy the very physics we thought we understood. We, the cosmic detectives of Earth, found ourselves sifting through evidence that seemed to contradict itself at every turn, each perplexing clue deepening the mystery of this astonishing visitor from another star system. Imagine, if you will, being handed a cosmic barcode. That's essentially what spectroscopic analysis allows us to do. When light from a celestial object is split into its constituent wavelengths, it reveals a unique signature. This unique signature, a precise fingerprint of the elements and molecules present in its composition, tells us what the object is made of, offering an intimate glimpse into its very essence. And when the James Webb Space Telescope turned its sensitive instruments towards 3I Atlas, the barcode it revealed was utterly astonishing, completely unlike anything we expected from a typical comet. The prevailing theory for comets in our own solar system is that they are icy dirt balls, pristine remnants from the formation of our sun and planets, largely composed of water ice. When they approach the sun, this water ice sublimates, creating the familiar coma and tail. But 3Psi Atlas sang a dramatically different tune. Its spectrum was overwhelmingly dominated by carbon dioxide, CO2, with shockingly little water vapor detected. Think about that for a moment. Instead of the familiar life-giving water, this interstellar wanderer was belching out vast quantities of dry ice. This isn't just a minor difference. It's a profound revelation about its birthplace. This hints at conditions far removed from those that shaped our own solar system. A CO2-dominant composition suggests it formed in an environment far colder, perhaps in a region of a protoplanetary disk. This isn't just a comet from another star. It's a comet from another kind of star system, one that fundamentally challenges our very models of planetary formation across the galaxy. It's a tangible fragment of a truly lost world, an ancient relic, potentially up to 7 billion years old, predating our own solar system and originating from the ancient thick disk of the Milky Way. This extraordinary chemical signature wasn't the only anomaly. While the JWST was meticulously decoding its spectral barcode, ground-based observatories like the Meerkat radio telescope were adding their own layers to the puzzle. They detected the presence of hydroxyl radicals, OH, a clear byproduct of water molecules being broken down by intense sunlight. This added a baffling layer of complexity to the already strange CO2-dominant composition. How could it be so rich in carbon dioxide, yet still show these telltale signs of water? Was the water simply locked away deeper within its nucleus, released in smaller, more elusive pockets? Now let's talk about speed, not just its incredible interstellar velocity of approximately 210,000 kilometers per hour, but the peculiar way it changed its speed. We're talking about non-gravitational acceleration. Most celestial bodies follow the elegant, predictable dance dictated by gravity, their paths precisely plotted by the immense pull of stars and planets. But 3Psi Atlas was subtly yet persistently pushing itself off course. As comets approach the sun, their icy surfaces heat up, turning directly from solid to gas. These jets of gas, expelled into space, act like tiny thrusters, giving the comet a gentle, continuous nudge. But here's where the paradox truly began to bite. The amount of non-gravitational acceleration observed in 3Psi Atlas was truly immense, far exceeding what would be expected from a comet of its estimated size. To explain this significant acceleration, the object would have to be shedding a staggering amount of material, roughly 13% of its entire estimated mass, in the form of gas jets. If a comet were losing that much material, it should be displaying a massive, brilliant cometary tail. Yet, for much of its observation, the visible exhaust from its engine was inexplicably weak. It was like watching a tiny sailboat, perhaps a mere toy boat, moving at the speed of a colossal battleship, yet leaving behind only the faintest ripple, not the churning wake you'd expect. The numbers simply didn't add up. We were seeing a titanic force at play, but the visual evidence was frustratingly elusive. Estimates of its nucleus size varied wildly, with Hubble data suggesting a diameter somewhere between 0.32 and 5.6 kilometers. Even at the upper end of that estimate, the amount of surface area available for outgassing seemed woefully insufficient to generate the observed thrust. This wasn't just a puzzle, it was a fundamental contradiction. As 3Psi Atlas made its closest approach to the Sun, or perihelion, on October 29, 2025, the intense solar heating brought about a dramatic change. This was the moment scientists anticipated the most activity. Post-perihelion observations revealed something far more bizarre, a complex and almost chaotic structure. It wasn't just one stream of gas, It was a multi-jet fireworks display. And then there was the anti-tail. Typically, a comet's tail points away from the sun, but 3GU Atlas displayed a massive anti-tail that appeared counterintuitively to point towards the sun. This sudden dramatic increase in activity gave rise to a powerful new hypothesis, the catastrophic fragmentation theory, inspired by the stunning disintegration of comet C319Y4, the Atlas. If the nucleus had shattered into at least 16 major fragments near perihelion, it would suddenly expose a vastly larger total surface area to the sun's intense heat, providing an elegant solution. This could explain the enormous outgassing required for its intense acceleration, as well as the sudden brightening and the complex multi-jet structure. It was an elegant, if violent, solution to a profound paradox. But even this compelling theory raised more questions than it answered. What exactly caused the fragmentation? Was it simply the crushing stress of solar heating, or something more intrinsic to its alien composition? And if it fragmented, where were all the pieces? The race was on. With telescopes working overtime during the post-perihelion campaign, trying to gather every last precious photon before 3GU Atlas vanished back into the cosmic ocean. The universe is a master of disguise, and 3GU Atlas is its most cunning trickster yet. Every piece of data creates a cascade of scientific paradoxes that challenge our very foundations of astronomical understanding. We've seen a comet that shouldn't exist, accelerating with a force that defies explanation. It is a genuine anomaly, a cosmic calling card that whispers of realms beyond our current understanding. As scientists grapple with these impossible clues, one profound question lingers, a question championed by figures like Harvard's Avi Loeb. If conventional physics can't fully explain it, what then? Is there a possibility, however remote, that we are looking at something truly extraordinary, something that challenges our very definition of natural phenomena, something that compels us to open our minds to possibilities once confined to science fiction? The prosecution, representing Team Nature, presents a powerful opening statement, arguing that while 3GU Atlas is undoubtedly unusual, its bizarre behavior can still be explained by the destructive forces inherent in cometary physics. Their star witness, the concept of catastrophic fragmentation. Imagine, if you will, an ancient wanderer, a frozen relic, from a star system light years away, hurtling towards our sun at an astonishing 210 kilometers per hour. This incredible speed, an orbital eccentricity of 6.137, confirms its interstellar origin. But as it approached perihelion, its closest pass to our star, something extraordinary happened. Scientists observed what they term non-gravitational acceleration. This isn't the object suddenly sprouting rockets. It's the subtle, continuous push caused by material rapidly escaping from its surface. The James Webb Space Telescope, our cosmic eye in the sky, delivered a crucial piece of evidence. Its spectroscopic analysis revealed that 3GU Atlas wasn't primarily shedding water vapor. Instead, it was dominated by carbon dioxide gas, with surprisingly little water. This suggests the object formed in an incredibly cold environment, perhaps in the frigid outer reaches of a distant ancient stellar system, or even in the interstellar medium itself. This composition makes it inherently more volatile, more prone to sudden violent outbursts. Here's where the fragmentation hypothesis truly takes center stage. Picture a fragile, icy body suddenly exposed to the intense heat and radiation of our sun. The rapid sublimation of CO2, acting like internal pressure, could cause the entire structure to become unstable. We've seen this before. Remember Comet C2019 Y4 Atlas? Stunning high-resolution Hubble images captured that comet disintegrating into over 30 house-sized pieces, a cosmic fireworks display of destruction. This visually unforgettable event serves as a chilling precedent. Indeed, post-perihelion observations of 3I Atlas revealed dramatic changes. It underwent a spectacular five-fold brightening, transforming its color to a distinct green hue caused by the fluorescence of dicarbon and cyanide molecules. More strikingly, telescopes like the Very Large Telescope and Hubble began to resolve not just a simple tail, but a complex structure of at least 7 distinct jets, a veritable fireworks display, along with a massive anti-tail that appeared to point towards the sun. Team Nature argues that these are all signatures of a comet tearing itself apart. The sudden brightening, fresh, icy surfaces exposed by fragmentation, the multiple jets, gas, escaping from newly fractured fissures, the anti-tail, larger dust particles pushed by solar radiation. The energy paradox, a core mind-bending fact of this mystery, also finds an explanation. To account for its non-gravitational acceleration, it would need to be shedding an enormous amount of material, roughly 13% of its total mass. This would require an active surface area vastly larger than its estimated physical size. However, if the comet fragmented into multiple pieces, the combined surface area of all those smaller fragments would be enormous. This sudden increase in exposed volatile ice could explain the dramatic brightening and the continuous, subtle thrust. Now, the defense takes the stand, led by a figure who has become synonymous with challenging our cosmic assumptions, Harvard University's Professor Avi Loeb. His argument is that the very contradictions Team Nature attempts to explain away are, in fact, the strongest evidence for an artificial origin. Professor Loeb points back to the energy paradox. If 3I Atlas truly shed 13% of its mass, why did it not consistently display a massive, bright cometary tail? The unseen mass loss, for Loeb, is a significant red flag. Then, there's the composition. While Team Nature sees the CO2 dominance as evidence of a colder formation, Loeb points to the sheer imbalance. An 8:1 CO2-H2O ratio is starkly different from typical solar system comets. This isn't just a comet formed in a cold place. It's a comet with a fundamentally different chemical engine. The extreme orbital eccentricity of 6.137 and its incredible velocity undeniably mark it as an interstellar object. It's potentially 7 billion years old, originating from the Milky Way's thick disk, older than our own solar system. This means it has had an immense journey. But what about the complex multi-jet fireworks display? While Team Nature attributes this to chaotic fragmentation, Loeb might ask, are these jets too stable, too distinct, too organized to be merely the random expulsions of a shattering ice ball? This argument finds historical resonance in the precedent of Oumuamua. That first interstellar visitor also exhibited unexplained non-gravitational acceleration without any visible coma or tail. For Loeb, Oumuamua was the first anomaly, suggesting that perhaps some interstellar objects behave in ways that defy cometary classifications. The core of Loeb's argument is this: science should be open to all possibilities, including those once deemed unthinkable. He is not saying it is aliens, but rather, we should not automatically rule it out when the natural explanations struggle so profoundly. So, the jury is out. You've heard the compelling case for nature, suggesting 3I Atlas is an extreme yet ultimately natural phenomenon. You've also heard the audacious counter-argument from Professor Avi Loeb, proposing that persistent anomalies point towards technology. Regardless of where you lean, the story of 3I Atlas underscores a crucial truth about scientific discovery. This object, the third confirmed interstellar visitor, serves as a tangible messenger from a lost world, potentially 7 billion years old, carrying secrets from a star system far older than our own. The clock is ticking. As 3I Atlas continues its hyperbolic trajectory, speeding away, astronomers are engaged in a furious observation campaign. Teams utilizing the James Webb, Hubble, and arrays like Meerkat are scrambling to gather every last photon before this enigmatic stranger departs our solar system forever. The mystery of 3I Atlas cannot be fully explained, not yet. And perhaps that is the most awe-inspiring truth of all. It reminds us that the universe is vast, ancient, and full of wonders that continue to defy our expectations, compelling us to keep looking up, to keep questioning, and to remain open to the truly unthinkable. We left off with humanity engaged in a furious post-perihelion observation campaign, a global scientific sprint. Teams utilizing the James Webb Space Telescope, Hubble, and ground-based arrays like Meerkat are scrambling to gather every last photon, every last data point, before this enigmatic stranger departs our solar system forever. This race against time is not just about understanding one object. It's about pushing the very limits of our knowledge, preparing us for the dozens more interstellar travelers that advanced survey capabilities, like the upcoming Vera C. Rubin Observatory, are expected to uncover in the coming decade. As the sun sets on 2025, a momentous event is unfolding in the silent, frigid depths beyond Neptune. We are witnessing a departure. 3I Atlas, the third confirmed interstellar visitor to grace in our solar system, is making its final bow, hurtling away from our sun. At an astonishing velocity of approximately 210,000 kilometers per hour. That's about 130,000 miles per hour, a speed so immense it unequivocally confirms what we've long suspected. This object is not, and never was, gravitationally bound to our star. Its hyperbolic trajectory, with an exceptionally high orbital eccentricity calculated at 6.137, far exceeding even Oumuamua's 1.2 or Borisov's 3.4, means its path through our celestial neighborhood has been less of an orbit and more of a fleeting, almost straight line, a cosmic arrow shot from an unseen bow. The discovery itself, back on July 1st, 2025, by the Asteroid Terrestrial Impact Last Alert System Survey, was a moment of serendipitous triumph. This NASA-funded network of robotic sentinels designed to protect us from incoming threats instead found a profound mystery. What we have learned, thanks to the James Webb Space Telescope, is truly astonishing. Spectroscopic analysis has revealed an unusual composition, dominated by carbon dioxide with surprisingly little water vapor. Imagine that, an interstellar comet that's mostly dry ice, not water ice. Yet, compounding the puzzle, radio signals from the Meerkat telescope also confirmed the presence of hydroxyl radicals, a telltale byproduct of water broken down by sunlight. This adds a baffling layer of complexity to its CO2-dominant profile, pushing scientists to reconsider how these elements coexist. The energy paradox surrounding 3I Atlas is a core, mind-bending fact that continues to stump conventional physics. To explain its observed non-gravitational acceleration, models suggest the object would need to shed an enormous amount of material, at least 13% of its total mass. Such a massive loss should produce a bright, spectacular cometary tail, yet this has not been consistently visible, leaving us scratching our heads. The calculated mass loss required would imply an energy-absorbing surface area vastly larger than its estimated physical size. The debate surrounding 3I Atlas is heavily influenced by the Oumuamua precedent. Remember Oumuamua in 2017? That mysterious asteroid-like object also exhibited non-gravitational acceleration, leading some, notably Harvard's Avi Loeb, to propose it could be an extraterrestrial artifact. Post-perihelion observations revealed a complex and bizarre structure, including multiple distinct jets of gas and dust. We've seen at least 7 of these distinct jets and a massive anti-tail that inexplicably appears to point towards the sun, rather than away from it. And then came the dramatic 5-fold brightening after perihelion, coupled with a color change to a distinct green hue. This vibrant green, attributed to the fluorescence of dicarbon and cyanide molecules, offered a fleeting, breathtaking glimpse into its exotic chemistry. One key dramatic point in the narrative of 3I Atlas has been the fragmentation hypothesis, inspired by the disintegration of Comet C2019 Y4 Atlas, where Hubble captured stunning high-resolution images of it breaking into 30-plus house-sized pieces. Scientists have wondered if 3I Atlas itself underwent a significant fragmentation event. The closest approach to Earth for 3I Atlas is predicted for December 19, 2025, at a safe distance of about 1.8 AU, approximately 269 million kilometers. So, rest assured, this isn't a threat, but a profound opportunity. It's a chance to study a messenger from a lost world, a time capsule from the deep past. Analysis of its trajectory suggests 3I Atlas may be ancient, potentially up to 7 billion years old. That makes it older than our own solar system. Imagine a remote village nestled deep within an ancient forest. One day, a wise traveler arrives, a stranger from a distant land. This traveler, with eyes that have seen countless horizons, asks the villagers a profound question, a riddle about the very nature of their existence, a question no one in the village can answer. The village is forever changed. The traveler may be gone, but the question lingers. United by this shared mystery, the villagers embark on a quest. They begin to build new tools, to explore the forest deeper than ever before. The stranger's visit didn't provide an answer, but it ignited a mission. This, my friends, is us. This is humanity. And 3I Atlas is that wise, enigmatic traveler. We may never fully solve the puzzle of 3I Atlas, but its visit served as the perfect fire drill for humanity, a cosmic wake-up call. 3I Atlas directly inspired a new mission, a testament to our resolve, the Comet Interceptor. This rapid response craft is designed to chase down the next stranger that comes our way. It's our new tool, our new explorer. This object, the third eye to pass through our solar system, didn't just teach us about itself. It taught us about us. It showed us the gaps in our knowledge, the limits of our current technology, and most importantly, the boundless human capacity for curiosity and innovation. As 3I Atlas fades into the black, its trajectory taking it towards an unknown destination in the vastness between the stars, it leaves behind not just scientific data, but a legacy. It leaves us with a profound sense of wonder, a deeper appreciation for the mysteries of the universe. We left off with 3I Atlas, a cosmic messenger fading into the black, its trajectory carrying it toward an unknown destination in the vastness between stars. It leaves behind not just scientific data, but a profound sense of wonder, a deeper appreciation for the mysteries of the universe, and an unshakable determination to be ready for the next cosmic messenger. Imagine, if you will, the galaxy not as a scattering of isolated islands, but as a single sprawling continent, connected by a vast flowing river. This isn't a river of water, but of interstellar objects, cosmic driftwood, if you will, constantly washing up on the shores of star systems like our own. 3I Atlas isn't just a rock. It is a tangible piece of another solar system, a silent traveler carrying with it the chemistry of a distant land, blurring the line between us and the galactic neighborhood. It's an object that whispers of ancient origins, of cosmic connections, and of secrets that defy our current understanding. On July 1st, 2025, our robotic sentinels, the Asteroid Terrestrial Impact Last Alert System, or ATLAS survey, first caught sight of it. This NASA-funded planetary defense system, operated by the University of Hawaii, was designed to watch for dangers, for asteroids that might threaten our home. Instead, it found a profound mystery, initially designated C2025N1, Atlas. But its extremely high velocity, a staggering 210,000 kilometers per hour, or about 130,000 miles per hour, immediately signaled something extraordinary. This speed, far too great for our sun's gravity to hold, confirmed it wasn't a local. Its path was unbound, a hyperbolic trajectory with an astonishing orbital eccentricity calculated at 6.137, making its journey through our solar system appear almost perfectly straight. This wasn't orbiting. It was passing through, a fleeting visitor from beyond. This wasn't our first interstellar encounter. In 2017, Oumuamua, a mysterious asteroid-like object with no visible coma, also showed non-gravitational acceleration, sparking intense debate. Then came 2I Borisov in 2019, which behaved more like a typical comet from our own solar system. But 3I Atlas, it would prove to be in a league of its own, presenting paradoxes that continue to stump even our most brilliant minds. What truly sets 3I Atlas apart, and what continues to baffle scientists, is its strange behavior. It exhibited significant non-gravitational acceleration, a subtle but undeniable deviation from a path dictated purely by gravity. For comets, this usually means outgassing, material boiling off its surface, creating tiny rocket-like thrusts. But the paradox here is mind-bending. The calculated mass loss required to explain this acceleration seems to conflict with observations. This enigma deepened when the James Webb Space Telescope, our cosmic eye for infrared, turned its gaze on the 3I Atlas. JWST's spectroscopic analysis provided the first detailed chemical breakdown of the gases in its coma, revealing an utterly unexpected composition. It was dominated by carbon dioxide, with surprisingly little water vapor. To put this into perspective, typical solar system comets are icy worlds, rich in water. 3I Atlas, however, boasted a CO2-H2O ratio of about 8:1, a stark contrast. This suggests it formed in a very different and likely much colder environment than our own solar system's comets, hinting at a birthplace deep within a frigid, distant stellar nursery. Adding another layer of complexity, radio signals detected by the Meerkat telescope confirmed the presence of hydroxyl radicals, OH, a byproduct of water broken down by sunlight, further muddying the waters of its unusual composition. This unearthly signature, the ghostly acceleration without a visible trail, the bizarre chemical makeup, each clue only deepened the cosmic detective story. It demanded a massive surface area, vastly larger than its estimated physical size, of between 0.32 and 5.6 kilometers to sublimate enough material to explain its propulsion. This energy paradox became a core mind-bending fact. How could it be losing so much mass without showing us the evidence? As 3I Atlas neared perihelion, its closest approach to the Sun, On October 29, 2025, a mere 1.4 astronomical units away, scientists held their breath. This was the moment of maximum heating, of peak activity. They expected dramatic outgassing, perhaps even fragmentation. And indeed, post-perihelion observations revealed a complex and bizarre structure that only intensified the mystery. Instead of a single coherent tail, astronomers observed a multi-jet fireworks display of at least 7 distinct jets of gas and dust. It even developed a massive anti-tail, which, counterintuitively, appeared to point towards the sun, a visually striking and scientifically bizarre feature that defies easy explanation. This peculiar behavior led to a critical dramatic point, the fragmentation hypothesis. Inspired by the dramatic disintegration of Comet 2019 Y4 Atlas just a few years prior, which Hubble stunningly captured breaking into over 30 house-sized pieces. Scientists wondered if 3I Atlas had also undergone a significant, catastrophic fragmentation event near the Sun. Such an explosion or breakup into at least 16 major fragments could explain its sudden five-fold brightening after perihelion, coupled with a color change to a distinct green hue attributed to the fluorescence of dicarbon and cyanide molecules. More importantly, it could provide the massive surface area needed for the enormous amount of outgassing required to explain its non-gravitational acceleration. The ghost wake, perhaps, was just too diffuse, too spread out, to be easily observed until its dramatic breakup. Yet, even with this hypothesis, the strange composition and the sheer scale of the energy paradox left nagging questions. This is where the "is it aliens" debate inevitably enters the conversation, heavily influenced by the Oumuamua precedent. When conventional physics struggles to explain an anomaly, the door opens to more speculative, yet equally compelling theories. The leading voice in this alternative hypothesis is Avi Loeb, a prominent and often controversial figure from Harvard University. Loeb champions the idea that the object's anomalies cannot be fully explained by natural phenomena. He argues that an extraterrestrial technological origin, while extraordinary, should not be ruled out. His reasoning, provocative as it may be, forces us to confront the limits of our current scientific understanding and the burden of proof required when confronting true anomalies. The core conflict here revolves around the scientific debate between mainstream explanations rooted in cometary physics and the more speculative alien probe hypothesis. Following its discovery, a rapid worldwide observation campaign was initiated. Observatories like the Hubble Space Telescope, JWST, the Very Large Telescope, VLT, and the Meerkat Radio Telescope scrambled to gather as much data as possible during its brief passage. This was a race against time. 3I Atlas was heading out of our solar system forever. Perihelion, on October 29, 2025, was a critical window of maximum activity. Closest approach to Earth was predicted for December 19, 2025, at a safe distance of about 1.8 AU, or approximately 269 million kilometers. This post-perihelion observation campaign, from November 2025 onwards, became a desperate scramble for astronomers to observe the object as it re-emerged from behind the Sun, testing predictions about whether a massive cometary tail would finally become visible. Every precious data point was crucial, every image a potential revelation. The object's journey, from its initial detection to its final farewell, has been a cosmic detective story, forcing scientists to act as sleuths, racing to solve a puzzle before the stranger leaves our solar system forever. It's a testament to humanity's watchtowers, systems like Atlas, designed for planetary defense, but instead finding wonder. This story occurs in an era of advancing astronomical survey capabilities, with systems like ATLAS and the upcoming Vera C. Rubin Observatory expected to find dozens more interstellar objects in the coming decade, promising even more such cosmic visitors. But what does 3I Atlas truly tell us? Analysis of its trajectory suggests this object may be incredibly ancient, potentially up to 7 billion years old, originating from the Milky Way's thick disk, making it older than our own solar system. This makes 3I Atlas not just a comet, but a time capsule, a messenger from a lost world, from a star system far older and different than our own. And here, perhaps, is the true aha moment that 3I Atlas brings. The existence of objects like this lends startling credibility to the theory of panspermia. This isn't just about rocks, it's about the very building blocks of life. If objects like 3I Atlas can traverse the vast interstellar distances, carrying with them the unique chemistry of their birthplaces, then the question, "Are we alone?" might not be answered by a signal, but by a silent traveler, a piece of cosmic driftwood, carrying the seeds of life from one star to another. This object, this tangible piece of another solar system, blurs the line between us and the galactic neighborhood, raising profound questions about the transfer of life's building blocks. It forces us to confront the philosophical questions of our place in the universe. We are not isolated. We are part of a vast, interconnected cosmic tapestry, a galactic river system where material, and perhaps even the genesis of life itself, flows freely between the stars. The mysteries of 3I Atlas cannot be fully explained by our current understanding. It remains an enigma, a cosmic question mark sailing away into the void. But in its departure, it leaves us with something more profound than answers. It leaves us with the knowledge that the universe is far stranger, far more interconnected, and far more awe-inspiring than we ever dared to imagine. It leaves us with the profound realization that we are not just on an island, but on a shore, where the galactic river regularly washes up fragments of distant, unknown worlds. What will the next tide bring?